So the last piece in our initial discussion of pEpH diagrams, let's take everything we've learned about the pEpH expression for nitrogen, and we will use it to describe the relationship between nitrate ion and nitrite ion under specific solution conditions. So we're asked to consider the reduction of nitrate ion to nitrite ion in a natural water system. We need to write the balanced one electron half reaction for this process in acidic solution. We need to calculate the pE, having been told that the standard cell potential for a reduction reaction is 0.811 volts. We need to write an expression relating pE to pH and the ion concentration. And we need to determine the nitrite to nitrate ratio at a condition where the pE of solution is 12 and the pH of the solution is 5. To begin, we need to come up with the balanced one electron half reaction describing this reduction. So the chemical formula for nitrate ion is NO3-, and the chemical formula for nitrite ion is NO2-. This means that the nitrogen is going from a +5 to a +3 oxidation state, which is a 2-electron transfer. It's a 2-electron reduction, so the electrons need to go on the left-hand side of the equation. Following our rules for balancing half reactions, we would then add 2 protons to the left-hand side, since it's in acidic solution, to balance the overall charge, and we would end up adding a mole of water to the right-hand side to balance the number of oxygens and hydrogens. This right now is a 2-electron transfer, and when we write pE expressions, we write all our reduction and oxidation reactions in terms of a 1-electron transfer. So we would reframe this dividing everything by 2, 1 proton plus a half mole of nitrate plus 1 mole of electrons gives us 1/2 a mole of nitrite and 1/2 a mole of water. The reaction quotient for this half reaction would be the concentration of nitrite raised to the 1/2 power divided by the concentration of protons times the concentration of nitrate raised to the 1/2 power. So now with our balanced 1 electron reduction half reaction and reaction quotient in hand, we can make a start on writing the pEpH expression for the nitrate to nitrite reduction, which is the main goal of this problem. We can calculate the pE0 value for the solution by remembering that the pE0, the naught disappeared from the slide here, so please stick the naught back in right there. This is pE0, not PE. pE0 is equal to E0 divided by 0.0591, which is equal to 0.881 divided by 0.0591. 14.91 would be our pE0 for this nitrate-nitrite solution. Combining this with what we know about the Nernst equation, we take the reaction quotient Q, we take the PE value, and we fold that into the overall Nernst equation, which now says that the PE for the solution is equal to the pE0 plus the log of the reaction quotient Q, and we can simplify this to the pE0 minus the pH of solution minus 1/2 times the log of nitrite divided by nitrate concentration. From this expression, which is our expression that relates pE to pH and the ion concentration, we can now evaluate the nitrite to nitrate concentration at a pE equal to 12 and a pH equal to 5. We will simply plug our pE value in on the left-hand side and our pH value in here. We already know our pE0 value, so our equation becomes 12 is equal to 14.9 minus 5, that's the pH, minus 1/2 the log of x, where x is going to be our nitrate to nitrite concentration ratio. We can solve for x by adding 1/2 log of x to both sides. We then evaluate, subtracting 5 from 14.9, then subtracting 12, multiplying by 2 to get rid of our 1/2. We get that the log of x is equal to 2 times 9.9 minus 12, or 2 times negative 0.21, meaning that the log of x, our nitrite to nitrate concentration ratio, is equal to negative 4.2. If the log of x is equal to negative 4.2, to undo that log, we will raise both sides over 10, and we get x, the nitrite to nitrate concentration ratio, is equal to 10 to the negative 4.2. 10 to the negative 4.2 is 6.31 times 10 to the negative fifth. So we would conclude that the nitrite to nitrate ratio in the solution is the concentration ratio favors the nitrate by a lot, and there are plus 10,000 nitrate ions for every nitrite ion. So we would conclude the ratio of the nitrite concentration divided by the nitrate concentration is 6.31 times 10 to the negative fifth. If we compare that to what we saw on nitrogen's pEpH diagram, we could trace back those same conditions, looking at a pH value of 5 right about here, and a PE value of 12 right about here. And we see that in this region, nitrite is becoming a much less dominant species, and by the time we reach an activity of a PE value of 12, we're actually into the nitrate region, so it makes sense graphically that we have a lot more nitrate in the solution than we do nitrite.